Hello, hello, hello. We are recording. Hello, Vicky. Oh, Mafine. Mafine, you're here. I thought you. Oh, right. Yes. I'm sorry. Hello, Mafine. Take that back. Of course, you're here. Um, I'm thinking of an email. Irrelevant. Good to see you, and good to see you, Vicky, and good to see you, Victoria, and good to see you, Joel. Um, but I did get the email, and I totally understand. Sorry, not anybody's business. Okay. Hello, Gabriel. More to come. Oh, and I know you're always here. That's not the issue. I know. Um, and hello, Joel, and hello, Aminata. And I'm looking at the chat now, or am I? Good afternoon, Vicky for the double. Hello, Melanie. Good afternoon, Roger. Good afternoon, Mafine for the double. Thank you. Good afternoon, Sonam. Good afternoon, Gabriel for the double. Good afternoon, Zoe. Good afternoon, Joel for the double. Good afternoon, Victoria for the double. Good afternoon, Caitlin. Hello, Yedaya for the she knows where I live. That's weird. I'll keep moving. Good afternoon, Raina. And I'm just kidding. I'm at my office, which you should all know where it is. It's on the fourth floor. See you there tomorrow, I think, maybe. Good afternoon, Abid. Hi, Bridget. Okay, I really need to, sorry. I'm just gonna do physics today. Hello, Anthony. Good afternoon, Aminata for the double. All right. Ignore good afternoon, Lear for
Good
the
afternoon, Professor.
afternoon. Thank you for the double, for the voice. All right. I'm going to stop the nonsense. I don't even know what we're. Oh, okay. So let's just get. Just be clear. Whoa, hello, hello. Yeah, as you can see, I am a little bit. Okay. Yes, this is us. We're going to do physics in a second. As you may, I owe you a bunch of stuff. I'm aware it is not personal. I have not forgotten. But if you're still missing some documents for me or feedback, I'm aware and I apologize. It is me, not you. Um, we're still working on the Doppler effect thing right now. And I know I very quickly at the end of last class sort of rushed you through solving one case of the Doppler effect. I'm going to do it a little. I don't want to waste your time, but I will back up and do that case a little bit more slowly, carefully, and ideally maybe contrast it to a second case today. I'm not going to do all four. I will make clear, I want to make clear to you your ultimate responsibility. The Doppler effect is a very important phenomenon in physics for a lot of reasons. And it's important in this class for a lot of reasons. Your job ultimately is to be able to compare and contrast the results from four different cases of the Doppler effect. That is something you need to know how to do. Um, I believe you may already have even done this in a lab, or you will, or a lab board meeting, or you will if you didn't. I think you did. Um, you're going to see it again with me today. Like I know the homework problem's been sitting in your box for a long time, being very vague and possibly intimidating, just sitting there. But now I'm going to spend a second day on trying to break down for you how you solve a case or two. My big point is that once you see how to solve a case or two, it should be the same way of solving for all the four cases. But that doesn't mean you'd get the same answer for all the four cases. You want to know how to solve each of the cases, and you want to even know how to sort of predict like what type of answers you'd get for the four cases, and you want to be able to explain why the results compare and contrast the way they do. Like it is, okay? So this is usually this type of problem, Doppler effect, will appear either on the midterm exam or the final exam, and one or the other. It sort of changes every semester, but somewhere you need to know how to do this. Um, and then that brings me so I'm going to go back to it in a minute. I'm going to slow down and try to explain it. I'm not going to do all four cases. I'm going to do one or two, and then the rest is up to you to do it the same way. But before I go any further, then I just want to clarify. I believe I just put a posting. You confirm or deny. I believe I just put a posting in your side of Google Classroom regarding the midterm exam that we do have to have. I mean, I'm only slightly more interested in having it than you are, believe me, but we do. We do. Um, um, I had not remembered until an hour ago that we don't have school on Monday, April 27th. Excuse me. We don't have school Monday, March 31st. Someone just told me that. Therefore, unless you all tell me in the next couple of minutes, once I get rolling, look at the posting that's in Google Classroom that you just got. It should say that your exam will be due at the beginning of class period Wednesday, April 2nd. That's what it should say. And that means the exam would be posted for you the Thursday prior. Like normally you have from Thursday to Monday to do an exam, but we don't have school this time on Monday. So you're gonna get like almost a full week to do it, which is more than I would prefer, but that's the way it is. So the exam will be posted Thursday, March 27th, which is like 2 Thursdays from now, and then be due back. It does say, okay, thank you for confirming. Okay, thank you. All right, so then it's due back like right before class on April 2nd. We will talk more about it as we get closer, but some of you have had me as a professor before, so you sort of know how this works, and some of you have not. The thing I want to just confirm right now, the thing I want to just confirm that someone is that you don't all have like an orgo. I mean, unless you all tell me that you all like have an orgo exam or something right in the middle of that, or some conflict that applies to all of you in that way, unless you all tell me that in the chat, I'm going to assume that this posting is okay, that you can live with this. And we will talk about the details of it as we get closer. But what you just need to know right now is that it's a take-home exam. Presentation and thoroughness of process absolutely matters. It's all about taking the problems and breaking them down to 5-step method and making your thought process and your full solution as clear as possible and as thorough as possible. So you're like treating this exam as though it's homework assignments that you've been doing to practice for this. You're giving me as thorough and well presented a document as you possibly can. You're using different colors if you can. You're making your handwriting as neat as possible or typing it. It will be a multi-page document that you will submit to Google Classroom right before you come to class Wednesday the 2nd. Then you will come to class, and that is part of it. Like the exam ends when you have finished being with me in class that day, having already submitted on time what was due, the full document, submitting it right before class starts. You're going to do this at home. You're not doing it under exam conditions. It counts as an exam. It is an exam, but really you should think of it more as like a paper presentation or something like that, because you are highly advised to do a rough draft first of all the solutions to the problems, and then like make a neat copy that is a self-sufficient document, something that I can follow without looking at anything else, including I shouldn't like you're giving me a full blue booklet in effect. I mean, it's not literally a blue book, but you're giving me an exam, a full document of all your solutions to the questions. And just like with homework, you're not copying the questions or copy pasting or including them or anything, but in every time you do a thing, you're doing the 5-step method. So you're making the question super clear and labeling like part 1, part 2, part B, whatever. And so I should be able to follow your document without looking at anything else but your document. And your document should walk me through, making it clear that you understand everything you're doing step by step. And the way to prepare and practice, I think there's things happening in the chat. I'll check. The way to prepare and practice for it is to notice that there's already an exam from last semester posted under exams, in the Google Classroom, that's your practice exam. Your actual exam, you're not turning that in for a grade, but that is a super similar, I mean, that's a super accurate representation of what you should expect on your exam. So you practice that thing and you go to old videos and find where I walked through that thing, and I did, and you just have to find them. I mean, they're usually called like MT walkthrough or something like that. Um, and or you go to the MSRC session that they're holding to review for this exam. I think you got emails about this, and the way they're going to prepare or review, have this review session, like literally they have that document, the exam from last semester. So that's the practice for the actual exam. It's the best guide there is to the actual exam. That's what you prepare and study. And as we get closer to your actual exam, if I have to make adjustments, if I'm like, oh, we didn't really learn this well this semester, or we emphasize this, if I have to make adjustments to your actual exam, I will accordingly make adjustments. I will update your practice. So it only gets more and more, it only becomes more and more of an accurate representation of what your actual exam will look like. Okay, so the way you study and prepare is you try to knock the bejeebers out of the practice exam. And then when your real exam is posted Thursday night, it won't be a surprise. Or, I mean, you have to still be careful and do it. Like the numbers will be changed and there will be changes, but it won't be out of nowhere. The topics won't be a mystery or anything like that. You're just then going to give a full, thorough document. And I know there's things in the chat. I will totally look in 1 second. But I think you get what I'm saying. Well, we'll find out in a minute if you get what I'm saying. But the emphasis I'm placing here, and we will talk, I'll answer more questions as we get closer, but I'm just trying to put it out there now we're in the mode where like an exam is coming. Um, and to that date and everything. So just know, because you have a practice exam document, because you can like do look at all these old videos and stuff like that, and because yes, it's a totally take-home experience on purpose. It's a take-home experience, not under test conditions. I know that I know you'll have access to pretty much all of the most of the answers you're going to have access to, and they're all over the web. And like even the questions that are changed slightly from the original, you have plenty of time to figure out how to do them. And I know that I know that the answers are out there and stuff. So your job in the document is not just to give me correct answers. We already have the correct answers. Your job is to show me that you understand why the correct answers are the correct answers. So you're walking through each problem. That's why we've been practicing that in the homeworks. You're presenting as thorough and convincing a derivation of everything as you can. And any time a new concept is introduced at the beginning of the exam, you over explain it. Then once it's introduced, then for the rest of the exam, you could say see above, or whatever, but you over explain everything at the beginning. You treat, okay? And you always act as though at any moment you and I could be in office hours having a private conversation about this, and I could be asking you questions like, how did you get this? How did you get this? How do you? And as long as you can answer all those questions, then we're both good. We're both delighted. But that's the standard, is that you know what you're doing and you're showing me what you understand, not just raw knowledge from the internet or whatever. Okay, I'm looking in the chat. Okay, hold on, I'm looking in the chat. Wait, oh, okay, thank you. It does say the dates are okay. Wait, and no, so unfortunately, yeah, okay, so there's some good questions, totally fair questions. And thank you for the people that are saying the dates are okay. Wait, actually, I'm just looking. You have an Oracle exam April 1st? Oh, wait, April 1st. That's a little annoying. Do you all have an Oracle exam April 1st? Wait, can I just look? Wait. Yeah, no, well, okay, wait, so sorry, hold on. If Do a lot of you have an Orgo exam on it? Well, all right. Well, I appreciate. Well, someone is pointing out there's an Orgo exam, but they're also being nice enough to say, I mean, yes, I am giving you the full. It's true. I'm going to post this thing Thursday night, and you'll have Friday, Saturday, Sunday, Monday, and Tuesday to work on it. So hopefully that will be enough. But if enough of you tell me that the whole Orgo thing is a big conflict, I may take it into consideration. But right now, one person's telling me I will think about that, because I don't like to conflict with Orgo, but. Um, So I'll take, but right now it's one person. Tell me, I don't know if there's a lot of other people in that person's class. Um, and also, just sidebar with this or the final exam, once we post these dates and stuff, make them official for the class, like, of course, for any one of you, if there's like a specific except, if one of you has an exceptional circumstance, okay, I don't want to have this whole discussion right now, but like with both exams, I mean, the midterm and the final, the main thing is communication. Like, it is true, I'm much stricter about timing of exams than I am about homework. Like, it is true that once I say it's due at 12:15, it has to be in before 12:15, and then you have to show up to class. Otherwise, that is a real problem and points are lost. But that means you can't just like be late with the exam without any communication. If you communicate well in advance, if like 4 days or whatever, if a number of days before the exam are due, if someone reaches out to me individually and says, I have this specific situation, I anticipate a problem. Can we work together to like possibly get an extension or an exceptional circumstance or something? If you reach out to me in advance and communicate politely about a situation, I can work with that. And with individuals. And if it's one person's individual turn on this midterm, then it'll be another person will have leeway on the final or whatever. Like if you have individual crises and situations, I can be human, but I just need you to communicate with me in advance to work with you to figure it out. Honestly, all of you. Okay. What I can't accept is that just 12:15 comes on the day that the exam due, and then just something just doesn't come in. And then you tell, and then like 20 minutes later, there's like a reason. Like, no, there has to be a communication in advance. Okay, just so you, okay. Now, as far as there's the good questions in here about like feedback and answers and drafts and stuff. What I will try to do is get you back more feedback on your, like, I have to catch up with a lot of your homework. I know that. And I will try to get you back more feedback on the homework before all this happens. That's sort of why we're announcing it like 2 weeks in advance or whatever. I would like to get you back more feedback on that so you can work with to do this. Yes, I'll do my best. When in doubt, I would say you err on the side of more, not less. On an exam, just if you ever think, I wonder if I should write this down. Should I include this step? The answer is yes. Just like the more you can explain, the better. Think of it as a presentation, not don't, it's not like a math test. I mean, it is a presentation. But yes, I will try to get you more feedbacks on your homeworks before then, yes. But then also people are asking, but the flip side is as far as what I can't do, just because there's literally no time, it becomes unfair. I will not be able to give you feedback on any draft you do. Well, first of all, definitely not on a draft of the exam. Like that's like not fair to other people. You should do drafts so you can see your mistakes and then polish it up and clean it up and make it neat. But I can't give feedback once the exam is posted. I can't give feedback on your progress there. I just can't. Furthermore, what I don't have time to do for everybody, and therefore it's not really fair for me to do for anybody, I can't give you feedback on the practice exam. You should do the practice exam for practice so you know what you're doing. And you totally can get feedback on the practice exam from like the MSRC or from possibly your lab instructor. I mean, well, definitely you can from your lab instructor, and she may, or he may, but I think it's she in this case, may even have a period devoted to that. Sometimes they do if they have time, and that's fine. If they do, that's great. And also, again, it's not that I won't talk about the practice exam in class as we get closer. Like, I will try to give you as much input as I can, but I can't take individual documents because there's just no time for me to do that for 150 people, and it really wouldn't be fair for me to do it for some. So that I can't do. But yes, I will. But solutions. Now, last thing is are there solutions to the practice exam? I will. They are all over the web. Like there are YouTube videos about them that you can find from prior semesters, and I will try to. I will, and your lab instructor may provide some. I will provide whatever I can. But but the point is, you've got like weeks to do all, or at least 2 weeks to do all of this, and you're totally allowed to work together and stuff. So
Professor, can I ask a question regarding that, please?
yes, yes,
So I asked about the full solutions. It's just because it's very clear to me, and I think that, even if I don't use any other external sources, that eventually I will get an answer. The thing is, I'm a bit worried about the 5 steps method. So this is why I asked if you have any full solutions for the practice exam. This is the only reason.
Yeah, that makes sense. And right, no, that makes sense. I appreciate it. So, I mean, the simple answer is yes, I have some, and anything I have, I will provide. Uh, And some of it now is in the hands of the lab instructor, and they will provide. So, I mean, yes, I will provide whatever I can. I just want to make clear that what I can't promise an exact full key to the entire practice exam. Like, I won't solve all of the problems for you for the 5 step method or not explicitly in one place because the actual exam itself is so similar to the practice. If I literally do that, then there's almost really nothing for you to do. So I will give you sample solutions one way or another, and I will make them available, but there has to
Okay,
be
thank you.
yeah, okay, yeah, cool. All right, you got yeah. But yeah, I won't. And I also say this to everybody. Usually, what it goes like is like anything that I'm pretty confident that I provided, like a PDF solution or anything that I'm pretty confident I gave you a 5 step model solution for a problem. Then I'll change the numbers. You have to be careful when you look at the actual exam, like in the solution I might solve for velocity, but then the actual exam I might ask you for acceleration or something like that. Like there'll be differences. So you have to be careful so you don't just copy what I said. But on the other hand, any problem that you and I, as we get closer and we see what's what, if there's a problem that you and I both know I did not provide a solution, often it's like problem 4. You'll see what I mean. But like if there's a problem where I did not provide a 5 step solution explicitly for you, that's also probably a good sign that that problem on the actual exam won't even be changed from the practice. Like then you think of that problem almost like research responsibility for you and your colleagues. Like if I don't give you the answer, then I know I didn't give you the answer. So now I won't even change it. Just figure it out. That's but the ones where I will try to give you model solutions, then I'll change them slightly for if that makes sense. But yeah, okay, sorry, I'm looking at, I hope that's somewhat, but good question. Wait, I'm just looking at the chat again. Feedback, right? Okay. Okay, I think that's all. Okay, so then there's one more question. Kind of idea how long the exam will take to compete, like 6 hours. Yeah, okay. And okay, here's a question that I like. Is there a kind of idea of how long the exam will take to complete, or maybe in comparison to the homework? Like, is it like 6 hours or like approximately the length of 2 homework exams, or how many problems we have to solve? Well, so yes, I can answer that. First of all, if you look at the practice exam, will kind of answer it for you. Like the practice exam has essentially it's essentially three significant homework assignments put together, which means, yeah, I would say this exam, if you literally just like sat down and did it under test conditions and you kind of knew what you were doing, like you've been sort of doing the homework in class and stuff like that, if you just sat down, I would say it's like a 4 hour experience or something to just like do it, maybe a 4 hour experience. Now I'm asking you to do a little bit better than just doing it. I'm asking you to like make it really nice for me to read. I'm asking you to sort of overdo it. So maybe to be realistic, I would call it like a 6 hour experience. But it is like three homework assignments put together. And you'll notice if you look at the practice exam, I believe often, now this is not a promise, but this is a uh, prediction. Um, Often it's like 3 or 4 homework problem type assignments put together, but then I give you choices. And often I do that. I'll say like, you have to do this one, but then do this one, or you have to do 2 of these, but then do what? So often the exam document itself is longer than anything you actually have to do. You will probably get a choice of some kind in yours. However, you won't know what that choice is until your exam is posted. So therefore, what I will say to everybody, look at the practice exam. Anything that's in that practice exam, you should know how to do because even if I gave a choice in the practice exam between this and that, I might give a different type of choice in yours. So you definitely want to be able to do everything that's in the practice exam. Um, I will up to as we get closer, if I start feeling like I've given you the answer to this, but I didn't really give you an answer to that, I will update it to make it more and more accurate reflection of what ours is going to be. But it's really the main focus is all about the practice exam. And as we get closer, I'll keep track of it. Believe me, to answer like Lear's question as well, like I'll keep watching the practice and see what do I owe them, what I need to give them a solution for this. I'm not going to give them a solution for that, whatever. I can't do all that right now, but I will. Um, so that's how it goes. And bottom line, I think I've said this before, but once this exam is posted, I know this is going to sound really strange to some of you, especially some of you who don't go to John Jay College. But when you take this thing home, once it's posted, it is a fully non-test condition experience. It's what I call open universe. Actually, I guess Lear already gets this because of the way he was asking the question, but I want to make sure all of you get it. Like, you can help each other. You should help each other. I know that sounds strange. And believe me, I've been doing this for a while. Don't misunderstand me. Like, I know what I'm doing with this. You can help each other and you should help each other. But that me and the MSRC can help you and your lab instructor can help you and the internet and Khan Academy and all my past videos, all of that you should use to help yourself. We live in this world now. Like, well, let's be realistic. Like, we live in the world of the internet. Like, I'm not fighting it. But what I'm telling you is you use all those resources to get yourself to understand the material better, especially for those of you, because I'm only communicating my way. It doesn't work for all of you. So you use one another and you use internet resources that I'm not a paid advertiser for, and you use everything to make sense and you show each other your versions of the 5-step method and see, like, do you think he would like this? Do you think, well, no, I got this homework back even though you didn't. So he liked this, but he didn't like that, whatever. You help each other so that at the end of the day, you could sit down at your desk the night before this thing is due and you can write out a final copy of everything you've gathered from all your friends, and you can write out a final document that totally convinces me that now you really understand all this stuff. Even if you only learned it the day before from your best friend or from your aunt who got a Nobel Prize in physics. I don't care. Like, right? Physics is, yeah, and you don't have to cite things. But at the end of the day, your standard is you are only writing down things that you understand and you're breaking them down enough that I can tell whether you understand them or not. And believe me, I can once you break it down enough. I mean, we'll get into that later, but like, and so I'll just leave it at that. And like, yeah, when in doubt, I mean, the easiest thing to do is just make sure that you're doing the 5-step method for everything and that you're labeling each step. Even I'll tell you right now, and this is back to Lear's question. I should move on a second. I know I'm not trying to scare anybody, but I'm trying to say in some ways, this is meant to be a much less stressful experience than a lot of exams often are in some ways, because you totally can help one another. And what you want to do is for every problem, literally label like step 1, step 2, step 3. If you literally had all 5 steps labeled for every problem, and there was like a lot of work for step 3, particularly step 4, you're almost assured that you're going to do okay. My style of evaluating the 5-step method is not actually as particular as you might think. It's first and foremost, do you have all the 5 steps? And the easiest way to know for you is to label them as you go. It's like you're doing your own grading rubric while you go. I'm not trying to blow off Lear's question. It's like a totally fair question. But I am also saying, just in case things get dicey or whatever, what you just want to do is break everything down into 5 and label it as you go. Um, it's the whole thing about this exam and we were doing it this way even before COVID, believe it or not. I mean, it's all gotten kind of refined since COVID, but the thing about this exam is it's designed, first of all, to take the surprise element out and to take the fighting against one another element out and to take me fighting against the internet out and all that stuff, right? And it's designed so that even those of you who are insecure about me or about physics, even those who are not sure you get physics or you're not sure you get me or whatever, as long as you actually take this very seriously and responsibly and give yourself plenty of time to make a really authentic document, it's super possible to do really well on this, even if you don't really feel like you totally are in command of physics or of me. As long as you actually authentically explain everything you're doing, you could even have a lot of wrong answers and still do really well. That's on the one hand. On the other hand, and I'm telling you this from experience, the other thing about this exam is, right, if you just try to dial it in or just get equations and stuff from the web, it's far easier for me to see that than you might think. If you just try to get answers or you just think that it's about results, not process, or you just go to, or you just get what your friends are doing and you just write it down, but you don't understand, it's far more transparent than you might think. And then that doesn't do well. And I'm not trying to scare anybody, but it's a document about integrity and authenticity more than anything else, really. Just okay, and we'll talk about it. This is not the last time we'll talk about it. I don't mean this as a scary thing, but just now that like it's out there, like that's where our ship is headed, and we'll talk more about it as we get close. Okay, I'm gonna chemistry. Yeah, okay, so someone just wrote the ultimate question. All right, I'm gonna move on, but I'm almost kind of hoping this is a joke. Well, maybe it's not a joke. Okay, this is the elephant in the room. Someone just asked about ChatGPT. Oh, it is a joke. Okay, actually, I'm relieved that it's a joke. Okay, but you're the first person to make. I'm relieved that that's a joke. But look, so someone asked about ChatGPT. Okay, of course you can imagine the number of faculty meetings that are devoted to talking about ChatGPT. And for all I know, half whatever. Here's the point. Like I am telling you, most of the things that you would ever consider cheating in a science exam or math, you can do on my exam. You can most of the things that you would consider cheating, you can do. And but I'm telling you, ChatGPT, can I stop you from using it? No, I can't. I'm telling you, this is a fully open universe exam. You can use whatever resource you want to figure things out and to try things out. When you go to write out the document, though, you have to assume that I could call you into my office and say, "How did you get this? How did you get this? How did you get this?" Okay. So what I'm telling you is, do I have a rule against ChatGPT? No, I don't. I mean, I know it was a joke, but I'm still going to say it. Am I even pretending that I'm putting a webcam in your house to see if you're using ChatGPT? Like, no, I'm not. In my experience so far at this stage of technology, even with premium ChatGPT, so far, I think it would be a big mistake. Like, I don't think premium GBT actually does do well on this exam so far. And believe me, I'm paying attention, right? Just like if you type in, I can't believe I'm getting involved in this right now, but if you type in Yaverbaum in Google Images, or at least this was true like as of last year. If you type my name into Google Images, you will find a whole bunch of solutions from Chegg to my problem. Like you'll see my font and every blah, like literally John Jay problems. And you'll see a whole bunch of Chegg solutions. Now, am I saying, and mostly they're homework, not exams, but whatever. And Chegg, of course, isn't supposed to do that, but whatever. Like, am I telling you that I can track whether you use Chegg or not? No, I can't and I won't. But I'm telling you, I've looked at those solutions and they're terrible. Like I don't, I like, you won't do well by using them. And is that arrogant of me? Yes. But, and will the technology be able to beat me? Yes, of course. But I don't think we're there yet. Like it just isn't designed for this type of thing yet. So be my guest, but it's a mistake, I think, to think that. I mean, it's basically why Lear was asking what he's asking, not because he's going to cheat, but like because it's already clear that I'm asking you to have a conversation with me that's a very specific type of conversation. And just knowing equations or knowing things is not good enough to be in that conversation. Anyway, I think you get my point. So use whatever resources you want to ultimately create a document, but know that the document is a conversation that you're having with me about what's been going on in this class. Um, and I've tried to have that conversation with ChatGPT and it hasn't worked yet. Like really. Um, okay. But okay. But I know that was a joke. Okay, okay. There was literally something I was going to say about. Sorry. We'll move on, but sorry, that actually just, or maybe I said it, the Chegg. Yeah, I mean, like there was a couple of years ago. I mean, honestly, there was a time when there were exams that I was like terrible. What's this? And they were getting bad grades, and it wasn't because I was saying I'm accusing you of cheating. I was just like, oh, this is not good physics. This is terrible. This is terrible. And then one of my adjunct, like another professor, who's Professor Walters, the male, not the female, like came to me and looked at all, and he's like, yeah, dude, all of those are from Chegg, like that. But I didn't even know that, and it didn't even matter. You see what I'm saying? Like, it's just the quality is terrible, like right now. Um, so don't trust it. Whatever, whatever. All right, I'm gonna. There was something else I can't remember it, but all right, I'm gonna um. Sorry. Okay. All right. So I'm going to go on. I'm going to go back to Doppler and try to slow down the Doppler solution now. All right. Unless there's more, but hopefully this is clear. Okay. Changing the view on the screen. And if I got carried away and I didn't answer your questions, like put them in the chat. But okay. This thing right here on the board, the first part, in principle, is the fifth form. I mean, in reality, it's the fifth form of Galileo's principle of relativity. Those of you who had me for Physics 203 ought to, I hope, recognize this. Those of you who didn't might not recognize this as that. Like it's, not everybody teaches this way. But what I'm just a quick reminder, the equations that are on the board is from classical mechanics. It's another, it's a mathematical expression or elaboration on the idea on Galileo's principle of relativity, which, as far as I'm concerned, all of physics boils down to. Like really, all of physics boils down to. Just there's many different ways of seeing the principle. The original principle of relativity is that the laws of physics are the same in all unaccelerated reference frames. Like the laws of physics are the same at all different constant velocities. And therefore, velocity is a relation between two objects always. It is never a property of one object, right? I.e., from the frame of reference of the Earth is going 0 miles an hour. Like relative to the Earth is going 0 miles an hour. But relative to and the sun is going past it at 65,000 miles an hour. But relative to the sun is going 0 miles an hour, and the Earth is going past it at 65,000 miles an hour. Velocity is always and they're both correct, right? Velocity depends on what frame of reference you're in. Velocity is a comparison between two objects. It's not an objective assessment of one object, right? So because velocity is always a relation in physics between two and never a property of one, the proper way to track velocities, especially when things start getting subtle, the proper way to track velocities is always to put two subscripts after the v and make it clear that you're talking about the velocity of a object, call it object A, relative to some other object like B or C or whatever, right? And once you start to, and I would claim that in the Doppler effect is a very important example where to understand what's going on in the Doppler effect, we absolutely need to track double subscripts because the Doppler effect really is what the Doppler effect is an expression or manifestation of the relational character of velocity as it applies to wave motion. Let me say that I'm saying the Doppler effect is where the motion of waves encounters the concept of relational velocity. It's both happening at the same time. That's what a Doppler effect is. Seeing how relativity plays out when what we're looking at is waves, not particles. So the relativity piece is this. I claim that Galileo's principle can be, if you want to think of it mathematically, as we're trying to, or symbolically, as we're trying to do here on the screen, like I would claim you could think of it in three different cases. The first, so I'm looking at the three equations at the top of the screen right now. The three different cases. Case one, here, like case one, case two, case three. How are these different cases like distinguishing themselves? Well, case one is the case of one object. Case two is the case of two objects. Case three is the case of three objects. If you have one object in your domain of discourse, if you have one object that you're thinking about, call it object A, then the velocity of A relative to A is always zero. If according to Galileo, right? According to this principle, if you understand the velocity is relative, then the velocity of something relative to itself is always zero, right? That's a truism that I believe it or not, I think we're actually using in the Doppler effect. Then if you have two objects, A and B, the velocity of one relative to the other is always the opposite of the other relative to the one, right? Like if you observe me moving 65,000 miles an hour to the west past you, then necessarily I observe you moving 65,000 miles an hour to the east past me. And we're both correct, right? Or we're both incorrect. I mean, we're both as correct as each other. Neither one of us is objectively on top of the truth, even more than the other one, right? So the one object case is saying that velocity is in effect is like reflexive, and this two object case is in effect saying it's like symmetric. Whatever I see you doing to me is what you see me doing to you, except in the opposite direction. Hence the negative sign. And then the third one, okay, the one that's the really subtle one that we talk a lot about in Physics 203, if you happen to have had me, and I'm not going to wrap, but we're going to really use here in the Doppler effect. The third one is how velocities add, right? That the velocity of me, well, I'll put in case of like the classic case, like subways, the velocity of me relative to the subway plus the velocity of the subway relative to New York City streets or relative to the platform or relative to the subway station, whatever you want to say. The velocity of me relative to the subway plus the velocity of the subway relative to streets equals the velocity of me relative to streets, right? And that's why I ride subways, so I can get somewhere without having to move, right? Like but really, if I'm in the subway and I'm going zero, I'm asleep. I mean, I'm sitting there. I'm zero relative to the subway, but the subway is 80 miles an hour relative to the streets. Hence, I am 80 miles an hour relative to the streets. That's how, but it works so well that even if I start walking along the subway, my velocity to the subway, like if I'm walking 2 miles an hour, then I'm going 82 relative to the streets. Or if I'm walking from the front to the back, then I'm going 78 relative to the streets, right? And in fact, even once angles are involved, even if none of the numbers is zero, and even if we're in two dimensions, that principle still holds. The velocity of one thing relative to another equals plus the velocity of another relative to a third equals the velocity of the first relative to the third, always. Maybe stop or maybe don't stop me, but let me know if that's like a big physics 203 thing. So that's the three object case of Galileo's principle. I say we're using all those. All of those are what's at issue. Well, all the time, they're always true. But then when a wave is going from a source to a receiver, all that stuff is true, but then you have this added feature that's only true of waves. The added feature is that a wave necessarily always goes at a constant speed relative to its medium. Like, right, which we cannot say. I mean, I know I like went crazy about this last week, but you can't say that about baseballs or electrons or planets or whatever. Once you're talking sound wave, once sound comes out of my mouth, it is going 340 meters per second relative to the air, regardless of what my mouth was doing. And that's really deep, actually. Like if you really think about that fact in itself, it shows how bizarre waves are compared to baseballs. I mean, like in other words, if an airplane is flying along and it makes a sound, the sound comes out of that airplane and is automatically going 340 meters per second relative to the air. So if the airplane is going like 320 meters per second relative to the air, it's like going almost as fast as the sound, right? And as you know, if the airplane goes a little bit faster, like if an airplane goes 340 meters per second, then it's going to ride along with that sound. An airplane can catch up to its own sound, which you could never do with a baseball. If you throw a baseball off the top of a train, it's always going to be a certain distance ahead of you, no matter how fast that train is going, right? I mean, unless the train sped up after you, right? But I'm saying, like, it doesn't matter how fast the train is going, the baseball gets the speed of the train. So, assuming it goes constant velocity, you can't catch up to your own throw. But with sound, you can, even without the plane accelerating. I know the way I just said it a minute ago sounded like I was saying that it was, but I'm not saying that. Like I'm saying, basically, I'm saying an airplane that's going literally at the speed of sound will make sound that it will ride along with. The sound will collect right next to it and it will ride along with that sound. And if it were then, for example, to go faster than the sound, it will break through the wall of sound, that the wall of big pressure pockets of air molecules that it just collected. It'll break through that, and that's a sonic boom. You can't make a baseball boom like that, but you can do it with waves because waves don't get the speed of their source. They go a certain speed relative to the medium, regardless of what the source or the receiver is doing. And whatever that speed is that they go, so the speed of a wave relative to the medium is constant and it always equals the wavelength of the wave relative to the medium times the frequency of the wave relative to the medium, right? So I'm saying that's a special feature of waves, which if we then combine with the relational character velocity, we get this funny thing called the Doppler effect, where, so now I'm going to go back to the example in a second, but well, yeah, we get this funny thing called the Doppler effect, where literally the source and the receiver of some wave can ultimately measure and experience two different velocities of that wave. The wave is only going one velocity relative to the medium, but if the source or the receiver is doing something that the medium is not doing, then they'll disagree on the speed of the wave and they'll both be correct. And therefore, but since they'll agree on the wavelength, since each crest of the wave has to be as far away from each other crest, like no matter who's looking at it, the lengths between the crests are going to be the same. Since the source and the receiver will disagree on speed, but agree on wavelength, they're going to disagree on frequency. And they're both going to be right. And that means if you're making a sound, if you're sending a sound from some source to some receiver, like the pitch that you sent is not the pitch that's received. Like even if you had tape recorders in both the source and the receiver, like you put the tape recorders next to each other at the end of the whole experiment, they're going to play two different notes. That's what we're looking at here, right? So the way, okay, so okay, I'm going to intentionally. Now, I know I did this already on Wednesday. I'm not, but I did it really fast, right? So I'm going to do it slower now, but also on purpose now, I'm going to do a different case. So you can see that the method is the same, but it's not going to get the same answer. Okay, I'm going to do, and I don't care which case, like there's four different cases. I don't, you know, I don't care which one you call case number one or case number two, but I'm going to intentionally do a different case this time. So here's the setup. Right, so this is the source. This is the receiver. Now we know it's sound, so sorry. So we know what's given, the speed of the sound wave relative to the medium of air is 340 meters per second. That's a given. And we know that in this problem, the frequency of the wave, according to the source, I think was given as 800 hertz. Stop me if I believe it was 800 hertz, but it might have been 500. Hold on one second, sorry. If you know offhand, you can tell me, that would save time. Hold on. Sorry, I don't know. Sorry. Oh yeah, 800. Yeah, okay. And 80. Okay. So we know those two things. And then for the different case, so in each case, one of the two objects, the source and receiver, is still relative to the medium, and the other one is moving relative to the medium. I did a case very quickly last time where the receiver was moving relative to the medium. Let me do a case where the source is moving this time. So let's say in this case, let's say that the velocity of the source relative to the medium is 80 meters per second. And let's say it's toward the receiver, and the velocity of the receiver relative to the medium, let's say, is 0 meters per second. In other words, so I'm doing a case where the source is moving it. So this is called the source approach case. Last time in class, what we did was the receiver approaching, I believe, or with the receiver receding. And now we're doing the source approaching. And the whole question, and I always label the direction that the wave is moving in, I always label that positive, no matter what case I'm doing. The motion of the wave is positive. And no matter what we're always solving for, is the frequency of the wave relative to the receiver. We know that the frequency of the source in this case is given. In this case, it's 800 hertz. We want to know what the receiver will measure. Now, I predict, before I do any math, I predict that the frequency of the wave as measured by the receiver, I predict it's going to be greater than the frequency of the wave as measured by the source, just because the source is moving in. I'm just picturing this. I think we said this last week. Like if there were waves coming in at the beach, water waves coming in at the beach toward me, and I ran toward them, or the thing making them came toward me, I think I'm going to encounter waves more often than if everybody just stood there. Just intuitive, right? I mean, because well, yeah, I can't say just physically, if you just picture it, I think if the source of the receiver is approaching the other, we're not making it take more time to wait in between each wave crest. We're creating a situation where you're going to wait less time between each wave crest. So I think the frequency as measured by the receiver will be higher than the frequency measured by the source. Stop me if that's my prediction, my intuition. And I think that would also be true in the case where the receiver approaches. As long as there's an approach, my guess is that the frequency number that we're going to get is going to be higher than 800. But let's see. How do we do it? Okay, and I'm just going to solve the exact same way I said last time, even though it's a different case, but I'm going to try to say it a little bit slower this time. Like, so sub-step 1, or sub-step A, if you like. Why do I call it sub-step? To go back to Lear's question, because I think if I were doing this on an exam, everything I'm about to do right now is like under step 4, right? I think step 1 is the diagram that I just drew. Step 2 is what is the question. I guess I'll try to do this right now. Like this is step 1. This is step 2. Like, what is the question? Step 3 is this, all this business here. Now, and again, if this were the exam, I would write out each one of these steps and I would add English. I would, what just happened? I mean, I think this is step 3, but I would annotate, like I would write something like this, but then like next to it in a different color or something in English, I would explain what these things mean. And you don't have to re-explain it every time you use an exam, but the first time you use it, I would explain. But this would be the core of my step 3. That would step 1. This is step 2. And then now we're going to start solving. So this is all going to go under step 4. And for Doppler effects, I think there's 3 sub-steps that I always follow to solve a Doppler effect problem. Sub-step A is solve for the wavelength of the wave according to the source. I always do this first. I don't care which case it is. I solve for the wavelength according to the source first. And how I do that always is, well, I know from step 3, I know that the velocity, the velocity of, here, I could even make this more general. Hold on. I'll even say here, this statement is true. You see this statement here, VWM equals lambda WM times FWM. Like that is true. I'm not taking it back. Like the velocity of the wave equals the wavelength of the wave times the frequency of the wave relative to the medium. But all of that has to be true relative to anything. Like it is true relative to the medium, but it would have to also be true relative to a source or relative to a receiver. Wavelength times frequency equals wave, whoever's looking at the wave. So, right, so if you want to make this more general, you could make this just A and B and A and B and A and B, like whatever 2 things you're looking at, it has to be true. So I'm going to say the velocity of the wave relative to the source must equal the velocity of the wave relative to the source times the frequency of the wave relative to the source. Let's see how I do my F's. Oh, I'm being inconsistent about how I draw my F's. Okay. Right? And therefore wavelength. So I'm just saying V equals lambda F. So lambda equals V over F. Right? But now here's the catch. Here's the part that I did really quickly last time that I want to make very slow this time. VWS. That means velocity of the wave relative to the source. Why am I looking at the source? Because I'm recommending to you that the best way, because I'm solving for the wavelength according to the source. And you'll see when we're done why I always start that way. But I'm getting the wavelength according to the source, therefore I use the velocity according to the source. Now, the velocity of the wave according to the source, I don't actually explicitly know. This is the key to the whole problem. I don't know. I might think I know it, but I don't. What I know, so I'll write this down. VWS is not given. Neither is VWR, which when we did the other case on Wednesday, we did, well, it doesn't matter. Like, we don't know the velocity of the wave relative to the source or the velocity of the wave relative to the receiver. Not explicitly, we don't. What's given is VWM. The velocity of the wave relative to the medium. That's what's given. Why? And I know that's given. I don't care what problem this is or if it's on the exam or not. Like, I know that's what's given because that's what's known about waves. We know how fast a wave is going relative to its medium. That's like speed of sound relative to air, right? So that's the given. But here, if we want to know the velocity of the wave relative to the source, how can we possibly get it? This is where we have to use Galileo's principle of relativity. We would say the velocity of the wave relative to the source is the velocity of the wave relative to the medium plus the velocity of the medium relative to the source. Now think about that on your own time at home, right? I mean, it's just a step, but think about the logic of it. I'm saying I don't know the velocity of me relative to New York City streets. But if I know the velocity of me relative to the train, and I know the velocity of the train relative to New York City streets, then I add them together and I can get, right? So same thing here. I don't know how fast, or I don't automatically know how fast the speaker observes the sound to be going. But if I know how fast the air observes the sound to be going, and I know how fast the speaker observes the air to be going, then I got it. So that's what I'm going to do here. And this is what you did in the other case we did last week too. If you look back in your notes or later on, you'll see we're doing the same thing there just quickly. And it just might happen that one of these two numbers might be a zero. So like it doesn't look like we're doing any math, but we are. So I'm saying this. We know that VWM is 340 meters per second. And VMS, nobody told me that. The velocity of the medium relative to the source. In other words, the velocity of the air. And these are all like velocities, like direction matters. Pluses and minuses matter. So the velocity of the medium relative to the source, I don't know. But I do know that the velocity of the source relative to the medium was given at 80 meters per second. And that's positive 80 because the source was moving in the same direction as the waves, right? If it's a different case, if it's moving back, then it'd be negative 80. But it's positive 80 in this case. That's what I know. What do I know? VSM. So VSM equals positive 80. That means VMS equals negative VSM, right? That's Galileo's principle. Case number 2. Case number 3 says if you got 3 objects, add them all together, and one of those objects in this case is air. Case number 2 says if I don't know how fast I'm going relative to you, what I can and should do is just flip whatever you're doing to me, right? So VMS, well, sorry. So VSM equals the opposite of V. Oh, no. I'm sorry. That is what I meant to do. So VMS, like what was given was SM, but what I need is MS. So the velocity of the air relative to the source is negative 80 meters per second. In other words, the speaker's sitting there and it feels air coming in toward it at 80, right? Therefore, this is all step 1 or sub-step 1, step A, whatever. Therefore, the velocity of the wave relative to the source is equal to, we said, wave relative to medium plus medium relative to source. So it equals 340 meters per second plus negative 80. In other words, minus 80. In other words, VWS equals 260 meters per second. Now, that's not an answer, but that's a big important piece of information. And of course, once you're used to all of what I'm saying, you possibly can just see this in your head, but I still want to see you explain it all. In the exam, so what I'm saying is sound is always going 340 relative to air. But we've got a speaker here who's moving through the air. So from the speaker's perspective, air is coming at it. So sound is coming out of it, at 340, but being in effect, if you like, slowed down by the fact that air, it's in a box of air that's going at 340, but the box of air is coming this way at 80. So every second, the sound is only 260 meters ahead of the speaker, not 340, because there's wind blowing it back, if you want to think of it that way, and you can think of it that way. I hope that makes sense. I'm saying, again, I'm going to move on, but I'm saying the speed of sound is the speed of sound. Yeah, it's 340, but that means it's the speed of sound relative to its medium, air. If anybody sees the medium doing something different or doing something different relative to the medium, then they observe something different. And that's the interesting thing, that it's just relativity, but it's relativity applied to waves. We don't have this Doppler effect or any of this analysis with baseballs or electrons or planets because there's no rule that says a baseball like has to go a certain speed relative to the air, right? There's like no medium involved with particles. But there is a medium fixing the speed here. Therefore, the velocity of the wave relative to the source is 260. Now I can finally plug in. So I can finally say, okay, so the wavelength of the air, the wavelength of the sound relative to the speaker is that velocity divided by the given frequency. In other words, 260 meters per second over the 800 hertz. So we'll get that the velocity of this wave relative to this source is approximately 0.325 meters. Now I'm going to pause right there. Well, here. If you look back at your notes from last Wednesday, I'm about to move on to sub-step B. But if you look like in the other case that we did where the receiver was receding last week, we did the same method. We said step one, solve for the wavelength according to the source. And we did the same method, only there was no 80 to subtract or add to the 340. It was a 0 because the source wasn't because we were looking because the source was not moving relative to the air back then in that case. So we did 340 plus 0. So the velocity was still just 340, like the speaker was just sitting there in the air. So we did 340 divided by 800, and we got a wavelength of 0.425 or so last time. Notice this time we're getting a different wavelength. We're doing the same method, but we're getting a different wavelength according to the source. So you have to be, but it's the same method. And what is this arguing? And I'm not done yet. We've got 7 minutes, but I'm saying just look, if the source is if the speaker is sending out these sound waves, but the speaker is like running into the sound waves as it makes them, doesn't it make sense physically? And you can see this all over the web. Like you can watch videos about this, like other people make videos about this. If the speaker is sending out wave fronts, but then moving toward them as it sends, then the wave fronts are closer together than they would be if the speaker just sat there. In other words, the wavelengths are getting compressed from what they otherwise would be because the way the speaker sends out a crest and then it like runs toward it and then it sends out the next one, then runs towards it. So their gap is not as big as they otherwise would be. But that's not the end of it. So that's just an observation. So when the source moves, it affects the wavelength. When the source doesn't move, it doesn't. But so there we have the wavelength. So what? So what do we do with that? Then I say, no matter what case we're doing, I go to sub-step B. Sub-step B, very important, very quick, but very important. It just says the wavelength of the wave according to the receiver must be the same as the wavelength of the wave according to the source. This is subtle. I'm saying from case to case, the wavelengths might be different. In some cases, the wavelengths are like shorter or longer than you'd expect. But no matter if you're in a case, the source and the receiver have to agree on the wavelengths. There's no way, like whatever this wavelength is, yes, it just got shorter because the source is, but by the time it comes to the receiver, they're still agreeing, oh, that is a 0.325 wavelength. There's no way that this receiver and the source could disagree on how far apart the crests are. So now we can just go to sub-step C and say, okay, we could solve for the frequency of the wave according to the receiver by doing velocity of wave according to receiver over wavelength of wave according to receiver, right? And what is the velocity? So I'm just going back now. Now I have the wavelength and I'm going to have the velocity. So I'm just going to divide to get the frequency. So I just go back in the other direction. But what is VWR? I don't explicitly know it. What I know is VWM. So I say VWR is just like I did a minute ago, VWM plus VMS. Same thing I did in sub-step A. And this is the same thing you do every time. The velocity of the wave relative to either of the involved objects or frames of reference, you have to use relativity to figure it out. But so VWM is 340. What's MS? MS is the opposite of SM. What's SM? In this case, it's 0. Right? And this is so there's always you're always doing this twice. And in one part it's 0, and the other part it's not. And it depends on what. Okay, I know I'm running out of time. So VWR equals 340 meters per second. So in other words, now we can literally say, fine, the frequency, I can go back to that page in a second if somebody wants me to. The velocity of the wave relative to the receiver is the velocity of the frequency of the wave relative to the receiver is the velocity of the wave relative to the receiver over the wavelength of the wave relative to the receiver. So in this case, it's 3. So in this case, it's 340 over the wavelength that we got, which was 325. Right? So FWR in this case will be like approximately 1046 hertz. And that's the answer. Note 1046 is most certainly bigger than 800. So it checks. That's the answer. Now we have 3 minutes. Let's pause for a second. I'm telling you that what I just did was exactly the same procedure as what I did for the other case, the receiver case, the case of the receiver moving last week. And in the other two cases, I would still do the exact same thing. It's a question of where I would put pluses and minuses signs. Like that's what would make a difference in the numbers. But what I'm trying to emphasize really is notice the procedure. Once you get you're not memorizing anything. You're literally saying, first, I'm going to get the wavelength at the source. I'm going to divide velocity by frequency to get wavelength. Then I'm going to say whatever wavelength I got has to be the same throughout the whole problem. So then I'm going to divide velocity by wavelength to get frequency. Right? That's all you're doing every single time. And it sounds like a circle. I'm going to say it again. I'm looking at the clock. We have 2 minutes. You divide velocity by frequency to get wavelength. Then you take that wavelength and you divide velocity by wavelength to get frequency. That's all you're doing. But it sounds like it would be a circle. It sounds like you should just be going, like you're not getting anywhere because you just did the same thing twice. But the reason it's not a circle is that the velocities that you're using for source and receiver are definitely different. Otherwise, there wouldn't be a Doppler effect, right? So you're dividing some kind of velocity by a receiver to get a wavelength. Then you're dividing a different velocity by that same wavelength to get a different frequency. And how do you know what velocities to use? How do you get them? You use Galileo's principle of relativity. You always do this thing of adding VWM plus VMR or VWM plus VMS. You're doing that every time. And in one case, there'll be a 0 involved, and the other case there won't. And how do you know whether to put a plus or a minus? You know because you always make the direction of the wave plus. Like that's how you do it. So you'll know you're doing this right. And we have 1 minute. If you should practice on your own, do the other 2 cases or the other 3, since I did the other one so fast, and you'll know you're doing it right. Well, I think you'll know you're doing it right. If you get 2 answers that are higher than 800 and 2 answers that are lower than 800, the 2 cases of approach should be higher than 800. The 2 cases of recede should be lower than 800, but they will all be different numbers. And that's the thing to think about. Okay, but it's 1:30. So thank you for being so patient. I will see you in 2 days. Thank you. Yes, have a good day. Oh, why is VMS? Oh, wait, I'm going to turn off the recording, but I'm going to answer that question. I see that.
Professor, may I speak to you as a class?